For this FRQ, you're given the differential equation 6x squared minus x squared y. Let y equal f of x be a particular solution to this differential equation with the initial condition that f of negative 1 is equal to 2. For part A, it says use Euler's method with two steps of equal size starting at x equals negative 1 to approximate f of 0. Okay, we're going to use this chart. You have x, you have y, then you have dy dx times change in x is approximately equal to change in y. And then finally, you're going to take the y value from this column and you're going to add to it the change in y that you got from this column, and that will go right here. Next, we're going to drop that value down to the next row. So we're going to start off with the initial condition that f of negative 1 equals 2. We're going to take x equals negative 1 and y equals 2, and we're going to plug them into the differential equation 6x squared minus x squared y. We're trying to approximate f of 0 with two steps of equal size. So that means we're going to go from negative 1 to negative 1/2 and then to 0. Each time we're adding 1/2. So that's going to be our change in x. So you get 4 times 1/2, which is just 2. Then we take this y value and we add to it this change in y over here in this right column. And what you get here gets dropped down to this next row. We're going to start the process again. We're going to take x equals negative 1/2 and y equals 4, and we're going to plug them into the differential equation that's given up here. So you end up getting f of 0 equals 17/4. Part B says at the point negative 1, 2, the value of the second derivative is negative 2. Find the second degree Taylor polynomial for f about x equals negative 1. So again, make sure you have your Taylor polynomial formula memorized. So our formula is going to be f of negative 1 plus f prime of negative 1 over 1 factorial times the quantity x plus 1 to the first power plus f double prime of negative 1 over 2 factorial times the quantity x plus 1 squared. And at this point, we want to plug in our values for f of negative 1, f prime of negative 1, and f double prime of negative 1. F of negative 1 is given, and it's equal to 2. We already found f prime of negative 1 in part A, and that's going to be right here, 6 minus 2 is 4. And we're given the second derivative of f at negative 1. The second derivative is given as negative 12. Last step, go ahead and simplify up these expressions right here. So our second degree Taylor polynomial is going to be 2 plus 4 times the quantity x plus 1 minus 6 times the quantity x plus 1 squared. Part C says find the particular solution, y equals f of x, to the given differential equation with the initial condition that f of negative 1 is equal to 2. So we're going to start with our differential equation 6x squared minus x squared times y, and we want to separate our variables. You want to leave x's on the right side and you want the y's on the left. So first thing I want to do is I want to factor out the x squared. Now that we have the x squared factored out and we have 6 minus y left, we can divide this expression over to the left side. So we've separated our variables. We have 1 over 6 minus y dy equals x squared dx, and let's go ahead and integrate both sides. Remember, on this left side, technically you're supposed to let u equal the denominator. If you let u equal 6 minus y and you take the derivative, you get negative 1. And the integral of 1 over u is going to be ln absolute value of u. So essentially we're going to plug the u back in and you get 6 minus y with that negative in the front. It's really important to put your plus c over here on the right side. At this point, we want to plug in our initial condition of negative 1, 2 to solve for c. So you get c equals 1/3 minus ln of 4. Once you identify c, you're going to plug it back into the first place where c showed up. Alright, at this point we have c plugged in and we want to solve for y. So we're going to divide out the negative 1 from both sides. At this point, to solve for y, we're going to exponentiate both sides using e. So the e to the ln, they undo each other and you just get the absolute value of 6 minus y. To get this y out of the absolute value, you're going to put a plus or minus on the right side. Okay, so now we have this expression with plus or minus e to this power. The plus or the minus will satisfy the initial condition of f of negative 1 equals 2. Because f of negative 1 is equal to 2, let's go ahead and check the positive option. And you can see that these are going to make 0, and then you get e to the ln of 4. So e to the ln of 4 would just make 4, and you end up getting 4 equals 4. So it worked out using the positive option. So we're going to use the positive e, and then we're finally going to solve for y. Divide both sides by negative 1. Okay, I'm going to split this exponent into e to the first part of the expression times e to the next part, and then e to the ln, they undo each other and brings that 4 down. Last step, I'm going to factor out negative 1/3, and here's my final answer. Y equals 6 minus 4 e to the negative 1/3 times the quantity x cubed plus 1.
In my heart, in my soul.